Anyway, so this is the Intro to Cortex, Cortex 101 talk. I'm Chris Marchbanks, maintainer of Cortex. Got a little link here for you to check out the project. I'm just going to do a guide into the system, how it runs, just about it. First off, a bit about me. I am a maintainer of both Prometheus and Cortex. Currently working at Splunk, building internal observability platform for our cloud systems. I'm passionate about all things observability, and in my free time, love getting outdoors, skiing uphill, hiking. Currently, it's super beautiful back in Boulder, so doing some scrambling. 2 days ago, I think this is when that picture was taken. Fun times. Start off with show of hands. This audience, who uses Prometheus? Hopefully everyone if you're in a Cortex talk. Great. Perfect. Who has multiple Kubernetes clusters or environments where they deploy Prometheus into? Also, almost everyone. So who runs Cortex now? A handful. Sounds about right. That's what I expect for an intro class. So, start with a little bit Kubernetes and just Prometheus. What's awesome? First class support. Prometheus is really awesome in Kubernetes. All of Kubernetes APIs are instrumented using it. And Prometheus has support for Kubernetes service discovery. Makes it really powerful. Huge community of users. Basically any question, you Google it, and there's probably 5 blog posts that show up about how to do this in Prometheus and Kubernetes. And the alerting and exploration of your metrics is really great and really powerful without any external dependencies. You just run a Prometheus server, it works, you can look at it, you can get alerts. You don't have to maintain a huge distributed system to do that. But there's some struggles. First off, storage is limited to local disk. That can be painful sometimes. And it's really hard to query and alert across multiple clusters, multiple systems. How does this cluster compare to this cluster over here? How much CPU am I using across my entire fleet? Those are hard to answer. You have to go out to, potentially dozens of Prometheus instances and compile all this data together. It's not great. So these are some of the issues that Cortex looks to solve. So why use Cortex? Global store of as many metrics as you need, with Prometheus querying and alerting capabilities. It's on durable long-term storage you don't have to manage. And it's across multiple tenants, which is a pretty unique feature. So here's some practical use cases. What does that actually mean in systems you're going to use? 1, long-term storage of all or a subset of metrics. Cortex just uses Prometheus remote write. You can send it all your metrics. You can send it only the metrics you care about. Whatever you feel like there. A centralized system for aggregating data from many isolated clusters. A lot of the times that cluster A doesn't have any communication with cluster B, and it's nice storing in this third place somewhere over here. Prometheus as a service. So that would be, for example, at Splunk Cloud, we use Cortex to provide Prometheus as a service to a bunch of dev teams. This can be internal or external, just depending on what your companies are doing. Then I'm sure there's a bunch of other use cases I haven't even mentioned here. Be creative. There's some super cool stuff out there I'm sure you could do. Here's a handful of companies that I know of that use Cortex. Starting that upper left, Weaveworks, big user. That's where Cortex originally came out of. They have super interesting data in that they let anyone on the internet go sign up and send them terrible, terrible data. So that's pretty fun. Then Grafana Labs, Aspen Mesh, EA, the gaming company, Electronic Arts is a super interesting one, powers all of their internal metrics, a whole lot of other companies. Cortex has been running for about 3 years in production, and I believe you can still query data from pretty much 3 years ago in those Weaveworks clusters, which is super cool. And we've just started with regular releases recently. They're all 0 point something. I think we're 0.4 is soon, somewhere in there, but that gives a bit more community and a bit more, you can see what's changing. So how does Cortex do it? So Cortex is built on the exact same code as Prometheus. We just take the Prometheus code, vendor it in, and use it. That means PromQL, exactly the same you're used to, and it works. And similarly, alert rules, recording rules, all the same syntax you're already used to using in your clusters. In addition to that, we make Cortex horizontally scalable, highly available. Instead of using local storage, you have NoSQL and blob storage for the data persistency. And then we embed multi-tenancy throughout, so you can isolate data between different customers, different internal products, however you see fit. Cortex is a CNCF sandbox project, and you can find it at that GitHub account. Hopefully website soon. Need to work on that. So yeah, start into it. Global view. So Cortex is a central system. Key difference between it and Thanos, which I'm sure many of you have also heard about. And you'll be able to send data from many different HA pairs of Prometheus to one centralized Cortex. The HA pairs in Prometheus world, if you want high availability, you run 2. Cortex will do the deduplication for you and all of that. And then you can graph it into your chosen graphing technology. Works pretty well. So now let's dig into what does that little blue circle actually contain here. At the beginning, the simplest way is just a single binary. It actually is mostly that blue circle. You send your data and your dashboards, point them to Cortex. You run one command, Cortex, pass it a config file. There's an example config file in our GitHub repo. If you're wanting clustered systems, you use some sort of key value store, etcd, console, something like that to keep a bit of state. Before too long, you might be able to cross those out. There's some experimental features for getting rid of that right now. And then you have a store, some sort of store connected, DynamoDB, Bigtable, something like that for the long-term storage of both the data itself as well as some lookup tables. Not too hard to stand up. But at some point, you're probably going to want to scale that. So in addition to that single binary mode, Cortex splits into many different components. And you can scale all those components individually. Typically in metric systems, you have way, way more writes than you ever do reads. And that path you will have to scale very differently compared to your query path. You can kind of think in Cortex there's 3 different subsystems. They're very helpful. First one, ingest, getting data in. Pretty key, can't do much else if you don't have any data. And then you can query, getting data out. And then finally, the rule and alert evaluation subsystem. So jump into each of those. So starting with ingest. This is how you would actually break out that Cortex. You still have your HA pair of Prometheus. It's sending data to a component called the distributor. And the distributor has 2 main roles. The first one is it will deduplicate samples. So rather than persisting data for all of the data, we'll actually only take samples from one of those high availability pairs of Prometheus instances, drop the other ones, and send off one set of data. And how that is calculated, it sends off the data to the ingesters based on consistent hashing of a specific series. You always know the data for one series will go to the same ingesters. In this case, it's usually a set of 3 ingesters, so even if you lose an ingester, you'll still have data, got some resilience there. And that is what etcd and console is for, is just keeping track of a distributed hash table for that. And then in the ingesters, you compress all of these samples that you're receiving into chunks. And these are the exact same chunk formats that are used by Prometheus. Dig into those just in a moment. After 12 hours or so, or when you stop sending any data to this series, you'll flush it to the long-term storage. You'll flush it to Bigtable, DynamoDB, Cassandra, anything like that. So a bit more into the compression. So the compression uses the same compression as Prometheus. Again, we just vendor in the same code. And it's based on the Gorilla paper from Facebook. The advertised data is that you can take a timestamp value, which would be usually about 16 bytes of data, and on average it gets compressed to 1.37 bytes per sample. So pretty awesome. That is, as you can imagine, quite a big cost savings compared to just storing everything into something like SQL. And then each chunk is sort of capped at a limited size. So by default, it's sort of 12 hours. But you can't have more than 12 hours of data in one chunk, and that will get flushed. And then for an idea of scale, there will typically be millions of chunks in memory in your ingesters. You can have billions of chunks, billions of series in the long-term store. And each chunk will be a few kilobytes in size when everything's done. So that's the ingest path. Next up is querying. As you can see, there's a couple shared components here. etcd and console are still used, and the ingesters are used for that recent data. So those are sort of the shared things you'll see. First off, who all was here at Tom's last talk about query front end? Few people, so you can see query front end component. That's where sort of the entryway into Cortex. It is optional, but especially if you were there for his talk, and if you weren't, check it out. He'll go into more detail of it than I will. It provides some really great benefits. It does things like splitting queries by day, so if you're doing month-long queries, even longer than that, which is pretty a common thing if you want a long-term store, is you're going to be looking at long data ranges. It'll split those queries up so they are executed much, much faster than if it was just a single thread. And it'll do things like query caching, and it'll fairly schedule queries. This is a multi-tenant system. You don't want one of your tenants just abusing the system and shutting everyone else out, so it'll fairly schedule queries across the different tenants. And then we move into the querier component. The querier component, it'll go to the query front end, say, yep, I need to do this query, gets the data, gets the query, and it'll actually do the PromQL evaluation. This embeds the PromQL engine from Prometheus, and it reaches out first to the ingesters for any recent data. As I was saying, sort of 6 to 12 hours of data is there, so you need to reach out, get the recent data, pull it back. And it'll also reach out to the store. So that's for any data that's already been flushed, series that have gone stale, things like that. It'll pull all of that data back as well, merge those sets together. If there's any sort of duplicate data, which can happen in some situations, it'll merge it cleanly and send it back to the query front end. There's also many layers of caching, making queries fast here. Like all, as Tom said in his last talk, like all software engineers, we like caches. They're great. And here's just a view of how the data flows in and out of the system. Prometheus on the left writes into distributors, which get written to the ingesters, and eventually flushed to a store. From the right, your dashboards, your whatever interfaces you use, go in, talk to the queriers. Queriers pull all that data back out from the ingesters and the store. So, cool, getting data in, getting data out. Haven't touched on rules yet. So how do you do rule evaluation and alerting across your clusters? So yet again, we have a component for that, multi-tenant, and it works. You have a ruler component, and again, we'll reach out to the ingesters via the distributed hash table that's stored in etcd and console, look at recent data, similar to the querier. Similarly, it also can reach out to the store and get any data. Most rules only look at 5, 10, 15 minutes of data, but there are some that need to go to the store, especially if you're trying to look into the future on disk space usage and things like that. After the rule is evaluated, it will then write back into the ingesters. So write the result of your recording rule into the ingester, and at which point it can be queried using the querier. Any alerts that go off are sent to the Alert Manager component within Cortex. Alert Manager, like all the other components, just vendored in upstream Prometheus Alert Manager with some multi-tenant wrappers. You can use the same alerting rule definitions you are used to and configuration that you are used to send off your alerts to VictorOps, PagerDuty, Slack, email, whatever you're alerting, whatever wakes you up in the middle of the night. And then sort of a little bit of recommendation here is that depending on your use case, I really like keeping the alerts in the native Prometheus still. And then use Cortex. It's really designed for these global alerts, global rule evaluation, things like that. And the reason it's nice for that is you want your alerts to be isolated from anything like, I don't know, how has anyone else just had external DNS stop working in their clusters? It sucks when that happens. And if everything is dependent on external systems, you're in for a little bit of sadness there. So keeping some of those rules local, highly recommend that, and use this for anything that needs to be across multiple clusters and things like that. And then lastly, sort of fourth thing, is long-term storage. Where do you actually put this data? I've just been saying store a lot. So there's a few different stacks available. First, sort of the AWS stack of DynamoDB and S3. And second, Bigtable and Google Cloud Storage for the Google stack. And then you can also have Cassandra for if you're not running in one of those cloud environments or just more comfortable running Cassandra. There's also BoltDB for local development options. Would not recommend using it for any data you want to persist long term. But it's there and it's great for just spinning up quick instances and playing around with Cortex. And then you'll notice like each of these both like Google has both a NoSQL database and a blob storage. The reason is Cortex has the idea of it separates data from index data and chunk data. So you'll see situations where you want to store the index data always in something like DynamoDB, Bigtable, these NoSQL stores, Cassandra. But the chunk data, especially if it's 3 or 4 kilobytes, the economics might be a bit different. If you're storing it for long amounts of time, it can be cheaper to store it into the blob storage like S3 or Google Cloud Storage instead. But all works. In addition, we provide some tools for automatically scaling DynamoDB. As load changes throughout the day, your DynamoDB scaling will change with it. Just some nice tools like that included within Cortex. Yeah. So what's new in Cortex world? First, super exciting, couple new experimental features. Ingesters now can create and ship blocks instead of those individual chunks. It's very experimental, but try it out. I'm super curious and super excited to see where this goes. And it's a great collaboration point with the Thanos community. We believe it's just a bunch of Thanos code vendored into Cortex at this point. And you can do the same queries like Thanos does. Hopefully save a lot of space and a lot of chunk storage, a lot less of that. And then, as I alluded to this earlier, but internal gossip has been implemented to remove the dependency on console or etcd. Hopefully at that point, one less system you have to deploy Cortex and just work internally. Experimental right now, but try it out. Have a good time, and then some upcoming work. First piece that I'm very excited about is write-ahead log for ingesters. Right now, all of the ingester data is stored in memory, which means if you say one of them ooms or something like that, that data is lost. If you have 3 of them, it's pretty rare that you will lose all of them. But it can happen, and this write-ahead log will make recovery way better, data resiliency way better, and just a little bit less stressful about losing single ingesters. And finally, query parallelization. I would again refer you to Tom's talk on Blazin PromQL in the previous session for more in-depth into this, but being able to issue out queries that you can break down individual queries into many different parts, that'll really speed up these big queries that commonly get sent to a Cortex system. And finally, I just want to mention Thanos. Super cool piece of technology, also part of the CNCF project. I'm guessing a fair amount. How many of you are also looking at Thanos or also curious about Thanos? Yeah, good amount of you. The big difference here is architecture. Thanos uses a decentralized architecture. You sort of store data out on the leaf nodes. Only needs object storage, which is pretty nice. It doesn't need the index and the object store. And if you want to check out more about just comparing them, there's a good talk from PromCon, a week and a half ago, 2 weeks ago now, with the link in the slides for just to see what's different between the two of those. Yeah. Anyway, with that, I would like to open it up for a decent amount of time for questions. Is there a mic? I thought there was a running mic.
Okay, I just got a question.
Great.
The experimental features, when do they get stable? Like, I don't like, depending on SCD, try and avoid it. But when do they get stable?
It's going to depend. Oh yeah, so his question was, I mentioned a couple experimental features. When will those become stable features? There's no formalized process for taking a feature out of experimental right now. It'll mostly depend on how many people actually use it, and when it becomes stable enough that a couple of the big companies that are deploying Cortex feel comfortable using it instead of console, instead of etcd, things like that. Is that? Yeah. Yeah. Test it out for us, and it'll be ready faster.
Thanks for the talk. How many people are working on Cortex, and is it mostly just at Grafana, or are there multiple companies involved?
There are multiple companies involved. I would say, I don't know, 10 or so people with reasonable contribution right now, and maybe half of those Grafana specific. And then there's still Weaveworks. You've got Brian over here. He does a fair amount of work from Weaveworks. We've had some work from DigitalOcean recently. I'm at Splunk, not Grafana. So I'll do a bit of work as well. And so there's a variety of companies across. Yeah. EA, well, I guess he's Microsoft now. A few different companies. What else? Great. Yep. Also, thank you, Tom, for running around a microphone.
Yeah, thank you. So Cortex is built with the multi-tenant case in mind, right? But if you take that out of the equation and you were just thinking of a single tenant solution, what would your preference be? And I'm sure this isn't the first time you've gotten this versus Thanos.
I think it depends on your system. So yeah, let's get rid of multi-tenancy. My first question that I look at is, are you aggregating data from many different locations? So if you are sending from many different Kubernetes clusters that they don't have an obvious network path between them, it can be a lot of the time simpler just to send them to a central store. And that's a pro that Cortex has. The second thing to look at is sort of costing and the system you want to deal with. Thanos, you spin it up and you just have to store it into blob storage. But it is missing the index. It's missing that index lookup, which can make Thanos queries slower than Cortex. Your mileage may vary on that. That's just a bit of my experience when I have spun up both of them. And the third thing is, and this is something that Thanos is probably going to be working on, is right now, Thanos, especially for long-term storage, if you have somewhat abusive cardinality cases where you had a point in time where there was just you had some cardinality disaster or something like that, pitch for Brian and my talk tomorrow. We're presenting a few cardinality disasters and what happens. Thanos on startup for their store component, you have to load all of the symbol tables and this metadata into memory. And eventually that can become very, very painful. And I think when we spun it up, we were giving it 200 or 300 gigabytes of RAM, and it wasn't loading our data after a while. And that was a point when we couldn't use Thanos anymore. So there's a few things to look at. If it's a relatively small cluster, try out Thanos. Try out a simple Cortex. See which one you like more. Talk to us more if you have specific use cases.
Anyone else?
You're making me run. Is it easier to migrate from Prometheus to Cortex without data loss?
From Prometheus to Cortex without like long-term data loss for data currently in Prometheus, I don't know of an easy way to do that.
I don't think we do that, no.
You could, this isn't easy, but you could effectively you could write historical data into Cortex via remote write protocol, that could work. But I don't know of any tools out there that just do it for you.
On that similar note, I know the TSDB provides an option to take snapshots. So could I take a snapshot of that and keep running to do remote writes? Would that help? Again, my oblivious question.
Yeah, so you'd take TSDB snapshot, and you'd have to upload that snapshot into Cortex.
I mean, PRs are welcome.
Yeah, it seems technically very possible. No easy way to do it now. And it seems more possible with the workaround just using blocks rather than chunks, because then you could potentially just upload a block and put some metadata around it.
But that's an upcoming feature.
Yeah, does not exist now.
Oh, it's merged the block stuff.
Yeah, the block stuff's merged.
Yeah.
That stuff's merged. Experimental.
Oh,
Yeah.
Any more? Oh, really?
Even though I'm sitting in the last row, I'm still interested. Thank you for your talk. Is there a way to do selective retention, so selective on only a specific kind of metrics, and to do different retention on specific metrics?
Not right now. Retention is just, it'll delete after X amount of time, user configurable amount of time. There have been definitely talk around different ways to do this, but nothing has been implemented to my knowledge, unless I missed some things.
Is there maybe an option planned or currently implemented, especially in S3 or something like that, for, I don't know, doing hot and cold storage, if you slice your things anyway?
You might be able to do it for the chunks, but I don't know of an option for that in DynamoDB. Not easily. You might be able to do some magic with prefixes and things like that, but I would not recommend it.
The block stuff should make that a lot easier once that's production ready.
Yep.
Any more? Brian, did you have a question? You were trolling me. Yeah, okay. Used to that. All done?
Well, thank you very much, everyone.
Thank you, Chris.
And have a great lunch.